Welcome back to our session on introducing the JIDT software. In this short video, I'm going to give you an introduction to the AutoAnalyser GUI, or the code generator. Now, this application is, I think, the most important demo that's distributed with the JIDT software. And that's for two reasons. Firstly, it gives a very simple GUI or graphical user interface for you to make some simple calculations with just a point and click interface. You don't have to write any code at all to start using the toolkit. You can calculate entropies, mutual information, transfer entropy, conditional variance thereof, just using the simple point and click interface. Beyond that though, apart from just calculating the answers for you, the GUI will create code for you, code templates in Java, in MATLAB and in Python. To recreate that same calculation on the same data file, you can take those code templates and extend them. So you might want to do a loop over a lot of similar files or something like that. You can take the code and extend it, and it gives you a really simple way to get started. So that's why I say this is the most important demo that's distributed with the software. Now, it's the most important information theoretic measures for the toolkit that are implemented in the GUI application. For other measures, please note that the general coding paradigm for all the calculators in our toolkit is the same. So even if the calculator you want to use is not one of the ones you can use in the GUI tool, you can look at how they're done there and use that to build your code with the kind of calculator that you want. So to start the GUI demo, it's really easy. You either just double click the jar file, or you can find scripts to launch the app in the demo's AutoAnalyser folder. There are shell scripts there if you're a Linux user, or batch files if you're a Windows user. And importantly, if you're on Linux, you need to set the executable bit before you can run those shell scripts. And the same holds for the jar file as well. So let's have a look. Let's actually run it. The first thing we're going to do is run the AutoAnalyser, and we're going to run a mutual information calculator with it. So let's have a look at that. So in our distribution here, this is the 1.4 distribution that I showed you in the last video. I'm going to point out that I've made a little cheat here. I've included a more up-to-date jar because I want to show you some more up-to-date features that will be in the next release, 1.41 and onwards. Okay, so it's a little cheat. It's not, what I'm showing is not necessarily in 1.4, but it will be in whatever version you should be able to use by the time you watch this video. As I say, we have two choices. We can double click the jar file to run it, or we can go to Demo's AutoAnalyser and run one of these two scripts here. If you run one of the scripts, you get a console window that gives you some extra output, and that can be useful if you run what we call an all pairs calculation. You'll see a lot more results there that you don't see if you just run the jar. That's something that we're going to fix soon. We're going to give you a console window if you run the AutoAnalyser from the jar in the future, but that's not there right now. As I also showed you on the slides, you need to set the executable bit if you're on Linux. If you're on Windows, you don't need to worry about that. I'll show you what happens if I don't do that. I get a warning that it's not marked as executable. So I'll fix that now. As I say, Windows users don't have to worry about this. Linux users do. That's done. We double click it and we're away. We've got the AutoAnalyser up and running. Now, I told you on that slide we want to do a mutual information. So let's pick that out, and we're ready to rock and roll. Let's flick back to the slides for a moment. Okay, so as I said here, computing mutual information could not be easier. We are now ready to go with our point and click application. All we have to do is just follow what's laid out for us on the GUI. Okay, there's 5 easy steps here. I'm going to flick back to the GUI and show these to you. So the first thing we do is we select the estimator we want to use. We can select a discrete estimator or various estimators for continuous value data, and we'll go through those in more detail in our next session. For now, we're just going to use the discrete calculator. We select a data file. We tell the calculator which columns of data we want to compute the measure between. There are some other more advanced things we can do that I'll show you later. What's important is that for each calculator, we have a set of properties that we can go through here. And when you hover on the properties, you get a description of them popping up. For example, here for the base, that's for the number of discrete values that our data should take. Once you've set all those, you can come down here and you can click Generate Code and compute. Coming back to the slides then. Once you've clicked compute, you get two very important things out. Firstly, you get your result down the bottom here, the result for the measure on that data set. Secondly, you get code to generate this calculation in Java, Python, and MATLAB. Code that if you run it will generate that exact same calculation. You can pick from these Java, Python, and MATLAB tabs to see the code in each language. And if you run that, as I say, you'll get exactly the same value. You can take that code and extend it to do more complicated things if you want to as well. So let's actually run a sample calculation. Okay, we'll follow the instructions here on the slide. I'm going to flick back and forth between the slides and the GUI. The first thing we want to do is select the discrete estimator. We've already done that from our drop-down menu. The next thing we want to do is select a data file. We want to select two coupled discrete cols from the default directory. Let's go have a look for that. Two coupled discrete cols. So we'll hit select, and the default location is our demo's data in the distribution. So I've got a whole set of sample data for you to use here. We're going to use two coupled discrete cols. So we'll open that. And notice that the very first thing the toolkit does is it validates the data file for us. Okay, it's telling us how many rows of data and how many columns. If we hover on data file, we get a brief description of here of what kind of data we should have. So it wants a text file of samples or time series values with the time or sample number increasing down the rows and variables going along the columns. We'll look at that in a bit more detail in our next short video. Once we've set that, we set which source and destination we want to compute the mutual information between. Now here, notice that the columns are indexed from 0. This is following Java or Python indexing. If you're a MATLAB user, you're used to indexing from 1. On the GUI, you're going to have to do it from 0 to fit in with the rest of us, I'm afraid. After that, as I say, we can set different values for the properties here. Let's go back to the slides and see what it wants us to do. So I've talked you through how we've checked the validity and what the format is. We've left the source and target columns as default. Now the example here wants us to set the base to 4 because the data is in the range of 0 through to 3. And it wants us to try what happens without this. So let's do that first. Let's go back and let's just try leaving the base set to 2. Okay, so that's telling the mutual information calculator that we're using binary data, but our data isn't binary. So let's see what happens. Okay, we get an error as we should, because our data has the range of 0 to 3, and that's outside the expected binary range for base 2. Okay, so we have to come in here and we have to set to use base 4, and then we can do things properly. Okay, so having run the calculator now, we get a result that looks pretty close to 0, and we get code here in Java, in Python, and in MATLAB. And each of these pieces of code will recreate the result for us in that given language. Let's flick back to our slides. So after we've clicked compute, we want to check that everyone got that same result that I did, 0.0007 bits, which, as I say, seems consistent with 0. We'll talk in one of the videos later in our course about what consistent with 0 means. As I mentioned before, we can hover on the property names to see the description for them. And in particular, we want to try changing the time difference property to 1. Let's go back and have a quick look here. Okay, so the time difference property tells us that we're going to compute a mutual information value from our source column to our destination column across that particular time difference. So at the moment, we use a time difference of 0, which means our samples are all in the same row in the data, but we can set a time difference of 1 to compute now a mutual information with a lag of 1 from the source to the target. Okay, our data file is actually designed such that 1 bit of our effectively 2-bit data is copied from the source to the target across a time difference of 1. So having put that time difference into the estimator, we should now see a non-zero result. Let's try that. Sure enough, we do. We see a 1-bit mutual information due to that 1 bit being copied across. As you see, it's a slight fluctuation, statistical fluctuation away from 1 bit, Again, we'll talk about these kinds of statistical fluctuations later in the course. Okay, so that's the end of our first example using the AutoAnalyser GUI with some discrete data. In our next short video, we're going to have a look in some more detail at the code that was generated from this example.